Because whether you are in power electronics or control, we always do measurements and instrumentation wherever we work. If you go to power control center, you see a lot of equipment, a lot of measurements even on their screen. If you go to power station, you see that they also have control room, like they have control room at Dangote here. So everything boils down to instrumentation to take those measurements. All right, so the first part is the earth resistance tests. Earth resistance tests. So now we are going to earth resistance tests. Earth resistance tests. Now, like I mentioned last week, when we install buildings like this, we carried out electrical installation. And we finish electrical installation in buildings. There's an important aspect that we do to, install safety into that building, to initialize safety right from the time power is being, installed into the building. Like for instance, we have a socket here. Usually when you open a standard socket outlet, you see 3 wires, not so? Yes, we have the live, the neutral, and the earth. The question is this: what is that yellow wire or green, which is the earth? What is he doing there? Is he also carrying power when we are using that socket? So why is he there? Is it not a wastage of money to now run wire, third wire that is not even working? It is not a wastage. It is for protection. It's for safety. And that is why it is important. When you have started working, don't go and do fake job for people. The job that may kill somebody in the future. As engineer, you must do the right thing. For example, you are going to install socket outlet for somebody, and they ask you, I don't have much money, please help me to resolve. You don't have much money, okay. Let me go and buy 3029. How many people know 3029? How many sockets have you installed with 3029 before? I know, that's what you do. Stop doing that. 2.5 mm for sockets or 4 mm. Don't do substandard work as an hello. As a learned person, you are not expected to do that. Do the right thing for them. If they don't have money, when they have money, let them call you back. But you will be afraid. And somebody else will collect that money, right? I know. But then when something happens in the future and that house gets burned or somebody got shocked or electrocuted, the thing will not be on your head. It will be on the head of that man, that fake contractor that did it for them. Now, when you finish installation like this, the earthing of the building, that third wire, is going to be tested. It is going to be tested. And in fact, not only that, the test we are looking at here is looking at the test you carry out on the ground outside. The ground surrounding the building must be good enough to remove electric current when there is a fault. Now ask yourself, when there is electric fault and there is a short from life to earth, what happens? What really happens in that instance? There's a problem. Current is, leaking to the earth terminal in a building. What happened at that point? Where is that current going? Or perhaps when you go to the building like this, you go to the building and saw big head, 2 big eyes, 1 hand, and we have a socket this way, and you did not know that there's a leakage between life and the earth, and then mistakenly you touch the earth. The earth is actually connected to the body of the appliances. Most of the appliances that have metallic surfaces have to be earthed also. And that earth, when you connect it to the socket now, the body will be touching the earth. And you are not aware. There's a leakage between the earth and the life. Maybe your freezer or something. What happens to that person? You said? No, not necessarily electrocuted. What happens normally? Receive what? Electric shock. Electric shock is coming like this. What actually is electric shock? What's electric shock in that person's body? What is electric shock? What is that electric shock? what constitutes electric shock that the person feels, or probably this person fall down due to the current. What is that? What is happening in his body? You don't know what is happening. Hello, if you want to answer, we have mic here. You said what?
The current is looking for a way to pass through the body, like a reverse action to looking for a way to like pass through to another source or other outlets.
Okay, you tried, but you have not got it fully. He has an idea of what is happening, like 6 marks over 10. So who want to help us? What is happening when current is shocking somebody? What is happening? Where are the distinction students? Where are they? Where are the distinction students? Let's answer this question. You don't want to show your face, Abby? It's okay, no problem. Let me help you out. Listen carefully. Current is passing through the body of this man, and current is finding its way, making that man part of a circuit that was instantly formed. And where is that circuit formed? The circuit is from here to the body of the man, to the ground, and back, traveling far to the transformer substation where that current is being supplied. A closed circuit must form. Don't forget, if there is no closed circuit form, will current flow? No way. So a circuit is being formed at that point when the person is receiving shock and the body of the person is making part of that circuit. The resistance of your body will just be a resistor in that current and determines whether the current will be so high or so low, and the resistance of the body is actually low. Now, current is traveling back to the substation transformer and moving in a circle back, round. Let's say the transformer is here. The transformer supply this the building normally, right? And then, as current is flowing through the body of the man, the current goes to the ground where the man is standing and travels back to the transformer, making a complete circle. Without making a complete circle, or circuit rather, the current cannot shock the man. He will not receive shock. And that is why sometimes you can touch a live wire without receiving shock. And we actually confirm that there is live on your body by using a tester to check it. The tester will show, but you will not receive shock. Do you know it is possible? Yes, I have done it before. Some of you might have done it also. But at that instance, hello, at that instance, listen. At that instance, you must not make any slight mistake. As you are holding the life, you must not make a slight mistake. Just by a small change, reduce the resistance of your body to the ground. For instance, let's say somebody just pour water on you. At that instance, pouring water on you will reduce the resistance of your body. And that time when you are holding that wire, you cannot just be coming from bathroom when you just finish bathing. I say I want to go and hold that wire. You are gone. Actually, the current that passes through the body of the man, there is one or two factors that determines whether the current will be so severe in the body of this man or not. And one important aspect that we are focusing on is the resistance of the ground through which the current will pass to reach the substation transformer. Somebody will be looking at substation transformer. How will current go and enter the transformer? Yes, it will. Because there is another earth thing at the transformer substation. Yes. Through those electrodes that were buried over there and the electrodes that were buried inside your house, a circuit will be formed. But at the time this man is receiving shock, another parallel circuit is being formed with the electrode that is buried around your house. Are you there? A parallel circuit is formed, and that parallel circuit that is formed, that is what we want to look at. In this house, where this socket exists, we have earthing, isn't it? Yes, sir. That's good. All right. Then when the man stands here, the man creates another path for the current to flow. Are we there? Yes, sir. Now, whether this man will receive a very heavy shock or not depends on this factor. The current that passes through the normal electrode to the transformer, that circuit, that path, does it have sufficiently low resistance or not? If the resistance of that part is so high and the resistance of the body of this man is so low, where will the current go through? Where will the current go through? The man is forming, a parallel circuit with this. Where will the current? Here is high, and the man's body is low. Where will the current go to? To the body of the man. So full current will pass through his body. And that time, probably he will even fit or fall down, and then we need help. Are you there now? But if the resistance of this circuit, the earthing of the building is so low, current will divert itself here more than the body of the man. And now, shocks me. Then we'll be able to even talk and tell you what happens. Because the current that actually passed through here is lower than the one that goes through the plane of the house back to the transformer. And that is why we want to tell you about these steps. Under normal standard installation, when you finish the installation, you must carry out earth resistance tests around the building on the electrode to check the behavior, the resistance of the soil where that building is installed, located. That is, the first of anything that we are treating. Earth resistance test. Somebody will be wondering, earth resistance test. So, does earth see the conductor? Is the earth a conductor? Why are we looking for its resistance? You see the reason why we must look for the resistance of the earth. Now, to save people, to save ignorant people, people that unintentionally get in contact with current in that house due to error, due to leakage or circuit or something, to save them from death. And you, as an engineer, must be committed to that, because you do not want the blood of somebody to be on your head. Yes, when you're not getting a project, don't now say, that one is small. It's small. To need. If somebody should die in the future due to that installation, God is looking at you, holding you accountable. Because listen up. Today, if you did not know before, engineer actually told you. So now you are being held responsible. What you should do in a building after the installation. Some contractors will even, after doing the earth electric, they will go and carry charcoal, salt, and things like that. Why are they doing those things? To reduce the resistance of the earth around that place, so that when there is a fault current, the soil will easily carry away that current down the body of the man in the house. I think you get it. Yes, so somebody might be wondering, some of you who work with contractors, you see that they are pouring charcoal, they are pouring salt, as if they are stupid. They are not. They want to save their head from the death of another man. That's what they are trying to do. Are you there now? So as an engineer, you must not do fake job. That is why this part of the course is very important. You must know what you are doing. You must be responsible for things that you are doing. Are you there?